This is the first solution of problem 24 from the fall MC12A from 2021. Convex quadrilateral ABCD has AB is 18, angle A is 60 degrees, and AB is parallel to CD. In some order, the lengths of the four sides form an arithmetic progression, and side AB is a side of maximum length. The length of another side is A. What is all the possible values of A? So here we have our roughly drawn trapezoidal-like shape. That's what you get when you draw the figure like that. So, well, let's just form variables for the other sides. We can call this lowercase b, lowercase c, and lowercase d. Well, this follows that we can say that angle AB has an angle measure of theta. So now we can use comparisons to help us solve this problem. Well, we can say that the square root of 3 over 2 times d is equal to b times the sine of theta. And this is true because the sine of 60 degrees is the square root of 3 over 2, where you're multiplying it by this side. And this is, so this holds true. Now, this basically means that something else is going to be true. Well, 1/2 times d plus c plus b cosine of theta equals 18. And yeah, this is one of the, so these are basically trying to find the sums of all these 18s, as you simply just drop the vertical from here and drop the vertical from here. So you're altering the b's and d's as they are the diagonals of the triangles that you form when you drop a vertical from points C and D. You can apply law of cosines to this. So after law of cosines, you will get that this is b squared times sine squared of theta plus b squared cosine squared of theta equals b squared. So that's our first equation we can have here. And, well, this is also true, so we can apply it again. 36 minus 2c minus d squared plus 3d squared equals 4b squared. So we have that. Equals there. So we have these two equations, and we can further elaborate in this case of law of cosines. We can also say that 36 minus 2c minus d squared is equal to 4 times b squared minus d squared. This, I'm going to write up here, can turn, well, this can just turn into 18 minus c times 18 minus c minus d. And this is equal to difference of squares, b plus d, b minus d. And we divided both sides by 4, as there was clearly a free factor of 4 in this equation. Okay? So, for the smallest c here, c value, we know that 18 plus c is equal to the positive or negative value of b minus d. Okay, so we have that. But that's when it's actually the not smallest for c. So we have that. Okay. Therefore, this means that C is 18 and A is equal to 18. So, therefore, there is now a new equation which we can write 18 minus C is negative as the negative of B, and 18, therefore, 18 minus C is equal to B plus 2D. There. But, well, let's see if this equation actually checks out. This equation is actually false as, well, negative B is clearly less than 0, and 0 is less than 18 minus C. So the second one's also false, where B plus 2D is greater than the absolute value of B minus D. This is only equal if C is the smallest. So 18 minus C is equal to positive or negative times 3 of B minus D. Since we know in this problem that C is less than 18, we also know that we can write that 8B is equal to 13D, or 8B is 7D. Now, we can start testing pairs for, or triplets for these values of side lengths, in which there's one such C, D, and B, where this directly corresponds to 3, 8, and 13. There is another CDB arrangement where this is equal to 12, 14, and 16. So we can now clearly write that A plus 18 plus this CDB, 3 plus 8 plus 13 plus 12 plus 14 plus 16. This is that's going to be a 9. So this is simply 84, our answer for this problem.